Okay, Math 30-1. So continue on this lesson here. Previous video, we talked about how to draw the angles, the glossary and the terms for different things like reference angles and standard position. Now we're going to talk about how do we measure these angles a little bit differently than we used to. So we are going to talk about radian measurements. So radian measurements is another way of measuring an angle other than degrees. It's kind of like kilometers and miles. They represent the same thing. You can change between the two. But one is more useful in terms of calculus and one is more useful in terms of communications. So what is a radian? So a radian is just kind of based on what its name is. The radian is based as its radius, right? If you would take the radius, right? Take a string about the same size as the radius. I don't have a string on me, right? And then take that string and kind of lay it on the outside of the circle. So that's the same length. So that this length is the same length as this other one. This is obviously not a straight line. It's curved around there. So that's why we call this an arc length, right? It's sitting on the outside of the circle. But if you did that, if you made these two to be exactly the same size, then this angle here at the center of the circle would be considered 1 radian. Okay? Now, the idea of this is that if I take it to 1 radian now, and I have a whole circle, right? And I did the same thing, and I kept doing it over and over again. So here's 1 radian, 1 radian. And then here's another radian. So I did the same thing again. So this is 1 radius long here. That's an R. Here's another R here. If I did it again, I'd have another R right about here. Right? Now, right across the circle, that would be 180 degrees there. So if I go from here all the way across, that's 180. So 3 radians is not quite a full circle. Okay? So 3 rads is not a full circle. It's just a little bit more. So this little itty bitty extra piece here is 0.14159 decimal. So there's 1, 2, 3 rads plus this little extra piece. If I added all that together, what I can say is that 180 degrees is equal to 3.14159 ... rads, right? So that is that, and this is actually pi. That's where the definition of pi comes from. Pi is this here. Pi pops up everywhere else. Now, I wouldn't say it's the exact definition of it, but that's one place where it pops up, and this is one place where you can actually calculate pi. Is how many radiuses can I put around a circle to get half a circle, or if I want to go the whole circle, I can just times everything by 2. 360 is 2 pi rads. Okay? This also gets us to a formula too, where we can use this ratio. If I know the radius of the circle, and I know how many rads it is, then I would know how long this circle is as well, or how the outside or the circumference of my circle. My circumference of my circle, if you look at this here, my circumference, this is the radius, right? Rads, radiuses are essentially the same thing. If I were to replace this, because 1 rad and 1 radius, 2 rads is 2 radiuses. So I just replace the word rads with radius, I would have now the calculation for the circumference of my circle. Okay? So that's essentially how this works. Okay. So these little fill in the blanks here, they're pretty self-explanatory, but this first box up here just talks about if I know my angle, and the thing is the angle has to be in radians for this to work out. If I know my angle and I know the radius of the circle, I can multiply those two things to figure out what this outside part of the circle happened to be. Right, so if I know my circle that I'm in right now, I know this distance, I know the angle. Say if I knew this distance was 5 and the angle was 1 rad, then this part of the circle on the outside here would be 5 as well. My radius was 5, 1 rad, 5. If it was 2 rads, and by here, 2 rads, this arc length would be 10. My radius was 5, 3 rads. I'm just multiplying those out together. So you could develop this formula where it says theta is equal to A over R, where A is your arc length. Right, so you got the arc length, and you could divide it by, sorry about that. You take the arc length, and you can divide it by the radius, and you can find out this angle, right? Or if I know the radius and I know the angle and it has to be in rads, right? Then I can find out the arc length. This is the arc length. It's a formula on the formula sheet, which is kind of nice too. Okay, so let's fill in some of these bubbles here, or these little blanks here. Consider a circle with R units for the radius. One complete rotation is going to be 360 degrees. Redundant to put degrees there. The arc length of one complete rotation around a circle is actually 2 pi radiuses, right? I don't like this lengths. I'm just going to get rid of that. So it's 2 pi radiuses. So that's just like here. If I put this all around here, I can fit 2 pi of these radiuses in there. Okay. So one complete rotation of this is the circumference of a circle. We already know this too, is 2 pi radius. That's what that's saying. The arc length of one complete is 2 pi radiuses. So therefore the circumference is 2 pi times the radius. I'm just going to put a little therefore. So that's where that comes from. Right? So if I put this into that formula up at the top there, the arc length is 2 pi r. The r's will reduce out, so my angle is 2 pi rads. And we already kind of talked about that over here in this little bubble on this side. So 360 degrees is 2 pi radians. 1/2, if I do the same thing, I could do the exact same thing over again with 180 degrees. A half a circle is 180 degrees. That's essentially how I started this. Yep.
Diana, could you come to my office, please? Diana, thank you.
Okay, so this is how I essentially started. Half a circle, I could fit 3 and a bit of a thing in there. So it's pi times the radius, right? So that's essentially what that would be. And then I can reduce this out and then look at this. I don't really like the way this is. I like the more logical way of how a radius is defined and how many of those radiuses I can fit around a circle. And they just happen to be the same in the rads. Okay, so this next little chart, it delves into what we deal with when it comes to radians. We like to try to keep our radians as exact answers as possible. But what we know, if I just type pi in my calculator, hit the pi button on my calculator, it's a repeating decimal, or not a repeating decimal, it's a non-repeating decimal. It doesn't terminate, it just keeps on going. It's pretty random. Actually, it's very random, right? It's not very exact. So to keep things exact, I have to use the pi symbol, right? It's kind of like using the root 2 symbol. That's not a very exact number, so we have to leave the root in there. So the pi is a very important thing. Pi is a non-exact answer or number, but the symbol pi is considered exact to mathematicians. Okay. So let's just go through this. If I want to change, we already know these two. So 2 pi radians. Now, if I don't put the word rads afterwards, you assume it to be radians. As soon as I put the symbol degrees on it, then it becomes a degrees. But if I just said, my angle is 5, because I didn't put the degrees there, I assume it to be rads automatically, right? So as soon as I put the degree symbol in there, then I know what it is. Then I know it's degrees. So 180 is a pi. Now, to go from 180 to 90, we would divide by 2. So to go from pi to the next one down, I would divide by 2. So we just write that out. We're not actually going to divide by 2 in a calculator and get 1.5707, 96, blah, blah, blah. We're actually just going to write pi over 2. Okay? To get from, say, let's go from 180 to 60, I would divide by 3. So that means I'm going to divide by 3 to get to this point here. Right? You can keep on going, like how to go from 180 to 45. So 180 to 45 is a divide by 4. Right? So I would divide by 4 to get to this point. Okay. Go to the last one over here, or the second last one here. I would divide by 6 to go from 180 all the way to 360. I would divide by 6. And to go right from 180 all the way to 1, I would divide by 180. So these are exact values. Okay? Now the rule here, if I want to convert between the two, there's actually ways to do this pretty easily. The way I do it is I set up a ratio. What I know is that it depends on which one we're trying to find. Let's say I'm trying to find the radians. I know that pi is to 180. So there's my ratio. Therefore, what is question mark? So I don't know, say we know what this angle happens to be here. Let's say I put 30 there. What is question mark? So if I know this is angle 30, what is the radians that corresponds to it? You can set the ratio up other ways too. You can go, you can put the two numbers on the same side, the ratio of the radians on one side and the degrees on the other side. And then you just rearrange this equation. So here I want to find out what the radians of this is. So I'm looking for the question mark here. Times the 360 up. Okay, times that 360 up. But I'm not actually going to do this math. What I'm going to do instead is I'm going to just look at this fraction part. Right? And then reduce that fraction down. So I go 300 divided by 180. You go math, enter, enter, and you get 1/6. And then you just leave the pi alone. So just put the pi back there. So this would be 1/6 pi, which we already knew up here was 1/6 pi. So you can multiply the angle in degrees. If you know what the angles in degrees happens to be, you can multiply it by pi over 180, right? But just make sure that when you want to get the exact answer, kind of ignore the pi, reduce the numbers down, the fractions down, and then just put the pi back in there. Okay, you're going to see that a few times when we go through this as well. Okay? So what I want you to do is I want you to use that knowledge that we have here and convert these 4 angles into radians. Hopefully you try that out now. So to change 270 into radians, I'm going to set up the ratio because I just like to set up the ratio because I know that pi is 180. So I'm going to put the 270 on the bottom over here and solve for the question mark. So you just notice that the degrees are on the bottom, the rads are on the top. Just cross multiply and divide. What I'm going to do is I'm going to go 270 divided by 180. Math, enter, enter. So when I cross multiply and divide, I'm really just cross multiplying and dividing the numbers, not the pi. Pi is the number, but just dividing the whole numbers there. So I get 3/2, and then I just put the pi back in there. So you can write that as 3/2 pi or 3 pi over 2, however you want to write it. It's the same thing. So you're going to do the same thing here. Get pi over 180, 315, look for that question mark there. So I'm going to go 315 times pi divided by 180. Yeah, enter. You get 7 over 4 pi, which should be written as 7 pi over 4. There you go. So this one here says convert these degrees into radians using the nearest tenths. So this time, if they say to the nearest tenth, that means that they want the pi in there. So you're going to actually do the math with the pi this time. So I go pi over 180. Put the 70 on the bottom, question mark. Now when I do the cross multiply and divide here, I'm actually going to use the math with the pi. So I'm going to go set 70 times pi divided by 180. And we're going to get an angle of 1.22. Now you can just leave it 1.22 because again, mathematicians to say if this is an angle, if this is an angle, then if I don't put the degrees there, I assume it to be radians. But just to be safe, just to be sure, you can put rads here, you can put radians as well, one of those two things. You just don't have to put anything if you don't want to. If I want this as an exact answer, fraction is not as nice, but we can still do this as an exact answer. 7 pi over 18 would be the exact answer in this situation. As soon as you put the pi in there, then mathematicians know for sure that this is a radian. The exact answer for this one is really ugly. This is going to be 41 pi over 36. But as a approximate decimal answer, 3 point, and this is nearest 10th here. Oops, I put that to nearest 100th over there by accident. But nearest 10th, it's 3.6 rads. Let's just change this down. Oops. 1.2 rads. Okay. Okay. Now to go the other way, we could just set the ratio the other way, where I could say, okay, well, we already know what 2 pi is. 2 pi is 360. Pi is 180. We kind of know what these other ones are going to be, but I would set up the ratio this way and say, okay, because I'm trying to find the angle this time, I'm going to put the 180 on the top, or the degrees on the top there. And then I'm going to put the other number on the bottom. So put the rads on the bottom, do the cross multiply, do the divide. So if I cross multiply and divide here, I'm going to get pi over 2 times 180 divided by pi, and I would get 90 in this situation. So cross multiply and divide, 90. What else are we going to do here? 180 divided by 3. 60 divided by 4, 45 divided by 6 is 30, divided by 180 is 1. Now, another thing to know is that there's a few different easier ways to do this as well. We know that pi rads is 180 degrees, so I can just replace all of these pi's with 180 degrees. I'm allowed to do that, right? So I could do that, or I could just multiply by 180 over pi, and that would work as well. Okay? So a few different ways to do this, like this one here, like I said, pi is 180. So I could just replace that with a 180, or I can multiply this by 180 over pi, and then you'll notice what happens is just the 180 divided by 5. So 180 divided by 5, so I get 36. This one has a negative in it, but that's fine. So I'm going to multiply this by 180 divided by pi. Notice the pi's cancel each other out. You don't necessarily have to. They do. So 7 times 180 divided by 3, so I get negative 420 degrees. Okay. Now, if we don't have a pi to cancel out, you still do the math. So you times it by 180 over pi. You could set up the ratio too. Like this is just set up the ratio here. 180 over pi is equal to 2.7 rads. Question mark, cross multiply, divide. That's essentially what we're doing there. So 2.7 times 180 divide by pi. Now, whenever you do degrees, you never have exact values of degrees. It might just end up being a terminated number. 1/10 of a degree. So you're always going to have some kind of decimal number here. So you're never going to have pi in your answer when you do degrees. So times this one here by, so let's do the nearest 10th of a degree, but I think this is going to end up being pretty nice. 180 divided by pi. Pi is canceled out. Oh yeah, it ends up being exactly 405 degrees. There you go. They're pretty good. You notice a little note down here, right? Many mathematicians, they just omit, which means they just kind of ignore the units. They don't write them down. But if you don't see units, you consider them to be radians. But as soon as you want it to be degrees, you got to put that little degree symbol in there. So I'm going to stop the video here, and we're going to talk more about arc length, the arc length formula that we used up here, which I think I should just move down there. We'll just talk about, I'll change this slide next year to just talk about how radians are developed. And then we'll talk about arc length down here. On the next video, I'll see you then. Bye.